It is finals week. We're going to do the practice final today. And like I just explained, once you're finished with the practice final, as soon as you're ready to take the final, you just give this to me. I mark that you're done with it, and then you can take that final. When you're done with both, that's it for this week. So we're going to go ahead and get started and run through all of these together. This is the best time to ask questions if you're not fully understanding anything that we are doing, because your final will be nearly identical to this. It will just have different numbers. So let's start on the first page, and we'll read the directions. It says, find the discriminant and state the number of real solutions. So I am going to get a sticky note out and write down the formulas that we'll need for each page of this practice final. So I need to know the discriminant formula. Does anybody remember that formula? The discriminant. What's that formula?
B equals B
Yes.
squared minus 4 AC.
Yes, D equals B squared minus 4 times A times C. So this is what we use for the discriminant. And remember, we get A, B, and C from our quadratic formula. AX squared plus BX plus C. A is the number in front of x squared, B is the number in front of x, C is the number at the end. Now, the other thing we'll need to know is how many real solutions. So let's make a guide. When our discriminant is 0, we will have exactly 1 real solution. Remember that? What about when our discriminant is less than 0, or if it's negative? How many real solutions will I have if I have a negative discriminant? Not 2. Not 3. 0. No real solutions. 0 real solutions. And if you want to make a note, this means that's when the discriminant is negative. Now, we also have a third option. Our discriminant could be greater than 0, or it could be a positive number. How many real solutions will we have here? 2. That's when we have 2 real solutions, when we get a positive discriminant. So this is the information that we will need for numbers 1 and 2. So starting with number 1, I have x squared plus 2x plus 1. What would be my value for A, B, and C? Yes, Rhonda.
A is 1.
A is 1.
B is 2.
B is 2.
And C is 1.
Good. And C is 1. Perfect. So let's use those numbers and just plug them into our discriminant formula. I have D equals. What number goes first? 2. Good. 2 squared. Then what? Minus 4 times 1 times 1. Okay. 2 squared minus 4 times 1 times 1. So I have everything plugged in. We use B, A, and C. What would I do next?
2 squared.
2 squared. What is 2 squared? 4. Now I have negative 4 times 1 times 1. What is that? It's just -4, so I'll bring down -4. So I have 4 minus 4, and what does that equal? 0. So what is my discriminant? 0. How many real solutions? Oh, this is where we need to be careful. One real solution. If our discriminant is exactly 0, when the discriminant is 0, one real solution. So you'll want to use this guide here to help you when you answer these questions. You'll only have 0 solutions if you get a negative number for your discriminant. So if you are just coming in, practice final is up on the wooden table. That is what we are going through now.
Something like that. Is it still today or can I leave?
You have some, like, are you not able to say?
Yeah.
Okay, yeah, you can, it'll all be videos. Okay, so let me just. Okay. All right, any questions on number 1? I'm going to scoot this down a little. We'll go ahead and look at number 2. I have 5x squared minus 3x plus 5. Who can tell me my values for A, B, and C? Jessica.
Your 5x is 1. Your -3 is 2, or B, and your +5 is C.
Good. Okay, so +5 is C. And then are we including x as part of B?
No, it's -3.
Yes, just -3. And so that +5 was also our A. Good. Okay, so I've got that identified. I know A is 5, B is -3, C is 5. If you're worried you'll forget the negative, might not be a bad idea to kind of circle that sign or just to write it off to the side. And how will I use these values? What should I write?
-3 squared
Good. -3 squared
minus 4
minus 4
times 5
times 5. Okay. Now on your calculator, this is where I'm going to see the most mistakes. -3 squared. Can I do this? Can I type -3 squared and get -9? Is that correct?
No.
No, that's not correct. Why is that not correct?
Because you have to put in -3 times -3.
Yes, because really what squared means is I'm taking -3 times itself, times -3. Two negatives cancel. It's going to be +9. If you want to type this in your calculator, you either need to put the parentheses around your -3 like this. Your parentheses are right down here. Parenthesis, -3, parenthesis, just like we wrote it. And then you can square it and you'll get +9. You could also type -3 times -3 and you'll get your +9. So now I know -3 squared is 9. And what should I do next? Multiply. What am I multiplying? I got 4 times 5 times 5. Or -4 times 5 times 5. And I'm going to get 100. Or if I included that -4, -4, it would be -100. So am I going to write 9 minus 100 or 9 plus 100?
9 minus 100.
Yes, 9 minus 100. The reason for that is because we have -4 and then we have 2 positive numbers being multiplied. So if there was another negative number, that could cancel and turn that into a plus, but we don't have any more negatives. It's just -4, 5, and 5. So now I have 9 minus 100.
Negative 91.
Yes, 9 minus 100 is negative 91. That's our discriminant. So how many real solutions are there?
0.
0. Negative 91 is less than 0. So there are no real solutions or 0 real solutions. And that is numbers 1 and 2. I'll put that little note up here. Leave that up for just a moment. Let everyone finish copying it down and start looking ahead at numbers 3 and 4. Now we're looking at quadratic equations. And we're going to actually solve them. So I'll go ahead and scoot my paper down a little. And for quadratics, whenever we solve for x, we have gotten very used to using the quadratic formula, which is x equals, anybody remember it? The quadratic formula?
X equals negative 3 plus or minus the square root
Good.
of b squared minus 4ac
Uh-huh.
over 2a.
Perfect. So, in case you forgot, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Little song helps you remember. But you don't have to remember if you write it down. Then it'll be on your paper. So this is the full quadratic formula, but if you bring your memory all the way back to the first few weeks of school, we broke this down into a less scary way to solve by making it a two-step problem where first we find the discriminant. First, we'll do b squared minus 4ac. Then, once you find the discriminant, we can use a simpler version of the quadratic formula, which is x equals negative b plus or minus the square root of the discriminant all over 2a. Then you only have to plug in 3 values rather than all those at once. So for the sake of breaking it down into simpler pieces, when we go through both 3 and 4, we're going to use the two-step process. So for number 3, I have x squared plus 3x minus 18 equals 0, and we want to find the discriminant first. So what is my value for A, B, and C?
A1, B3,
B3.
C, A minus A.
Yes, good catch. C minus 18, so negative 18. So I have 1, 3, negative 18. That's my ABC. Now we will find our discriminant. So what will I write to find the discriminant for number 3?
3
Uh-huh.
or
3 squared
plus minus
minus, good.
1
What's before 1? B squared minus,
or
don't forget the 4. 4 is part of the formula. Minus 4, then 1. And then what else?
Negative 18.
Yes, negative 18. Good. B squared minus 4 times A times C. So we have all our numbers plugged in. And what's 3 squared? 9. Now I have negative 4 times 1 times negative 18. And gives me I got 72. Is everyone else getting 72? You got negative 72.
I missed it, I didn't.
Okay, so if you get negative 72, that's okay, as long as you remember that we're subtracting negative 72, which turns it into plus 72. Yes. All right, so we have 9, and then what am I writing? Plus 72 or minus 72? Plus 72. And what is 9 plus 72?
Positive 81.
Positive 81. So what we just found is the discriminant, 81. So step 1 is done. Yes, Melena.
How do you know whether to do minus or addition?
Okay, how do you know whether to do minus or addition, subtracting or adding? Whenever you type in this second part of the problem, I would recommend typing in -4 times 1 times -18. So if I get, let's see, -4 times 1 times -18. If I get a positive number, like we did here, then you will add. If I get a negative number, like let's say this was a positive 18, and I had -4 times 1 times positive 18, and see, I would get negative 72. If you get a negative number, then you subtract.
I was just confused because on the last problem,
Mhm.
it was subtraction.
Yes, on the last problem, we had subtraction 9 minus 100 because if I type in -4 times 5 times 5, I got negative 100. So that's why we subtracted 100. But on number 3, we got positive 72, so we added 72. That's a great question. It's easy to forget which one to do, but it's as simple as if you're positive, add. If you get a negative, subtract. Okay, so we found our discriminant, 81. Now we can go to step 2. Let's solve for x. So I'm going to write this formula out, but I'm going to leave blank instead of writing B, D, and A. So I have x equals negative, that'll be B, plus or minus the square root of, that'll be the discriminant, all over 2 times, this will be A. What goes in the first blank?
B.
1 is A, so
B3.
3. Because we want B here, right?
Oh, I'm sorry. I was looking at the bottom.
Oh, you're okay. You're okay.
Your marker was like pointing right
My
at
bad.
that, so I thought that's
My
what you were
bad.
asking.
No, we'll have -3. You're okay. Plus or minus the square root of what goes here?
81.
81. Good. 81. All over 2 times, you just told me 1, because that's A. Okay, so we can now simplify and get rid of parentheses where we don't need it. What would I write at the next step?
-3 plus the square root of 8.
Yeah, -3. So I'm done with that. I'll bring down not just plus, but plus or minus. We want to bring both down, plus or minus. And I already have 81 by itself under the square root. Could I, at this step, go ahead and find the square root of 81? You could. It would be 9. So in case you forgot, on your calculator to find square root, second button, and then it's the x squared button. There's your square root. We'll type 81, enter, and we get 9. The square root of 81 is 9. So now I have -3 plus or minus 9 all over, what's 2 times 1? 2. Okay. So now I have x equals -3 plus or minus 9 divided by 2. What should I do next?
plus -3 plus 9 over 2,
Uh-huh.
and then -3 minus 9 over 2.
Yes. Now we split into the plus and the minus. We have -3 plus 9 over 2. And we have -3 minus 9 over 2. What's -3 plus 9? 6 over 2. X equals 3. What's -3 minus 9? Minus, you said 12? Okay, perfect. -12. -12 divided by 2, what is that? -6. So we're done. That's it. X equals 3 and -6. That is our answer. I know it's been a while since we've done these, but it's like riding a bike. You get right back up on it and it doesn't feel as hard as you thought it might. And then we'll do one more of these after number 3. Before we go to the next one, I want to give everyone a chance to write their work down and ask any questions that you might have. So I'll leave this up for just a minute.
I was repeating. Would it be okay if we just put like 2 decimal points around the second?
That would be fine, yes. You can do that, or you can write the decimal number that is repeating and do the line over it, but either one is fine with me.
Weird line, it mixes me up.
I get you. Yeah, you can just round up, that's fine with me.
I would just run into it.
Mm-hmm.
A little head.
Yes. Okay, we're going to go ahead and move to number 4. Same type of problem. What is my A, B, and C?
11 is B. And it's
Good. 3 is my A. 11 is B. 10 is C. So first, let's find the discriminant. D equals, what goes first? 11 squared.
4
Mm-hmm.
multiplied by 3
Good.
times 10.
Perfect. 11 squared minus 4 times 3 times 10. From here, let's simplify parts of this. 11 squared, what does that give me? I'm getting
121.
good, 121. Okay, and then -4 times 3 times 10. And we get,
120.
it is 120, but it's negative 120. So do we add 120 or subtract? Subtract. 121 minus 120
1.
is 1. So our discriminant is 1. Okay. And now that we have our discriminant, let's use the rest of the quadratic formula. Yes,
Oh, I was doing.
you're okay. So let's write x equals -b plus or minus the square root of the discriminant, which is 1, all over 2 A. Yeah, negative 11 plus or minus.
1.
Yes, our discriminant goes under the square root. Yes, and then 2a, 2 times 3. Perfect.
Which is 6.
It is. All right, so we plugged everything in, and now, just like we did on number 3, I'm going to draw kind of arrows to show where everything came from. We're just simplifying each part of the problem. So, I don't need parentheses around 11.
No.
That's just negative 11. X equals negative 11 plus or minus. What is the square root of 1?
1.
It's 1. So I don't need the square root anymore. I'm going to bring down negative 11 plus or minus 1
Over 6.
over 6. Good. 2 times 3 is 6. Now, let everyone get caught up to this point. Once we've done that, what happens next? Sure, go ahead.
You make 2 problems.
Make 2 problems. Our plus or minus gets split up. So what's my first problem?
Negative 11 plus 1 over 6.
Good. Negative 11 plus 1 over 6.
You get negative 10 over 6.
Now, before we go through that, what's
yeah.
our minus equation?
Negative 11 minus 1.
Good. Negative 11 minus 1 over 6.
Yeah.
Okay. So we've got those. And you said negative 11 plus 1 is negative 10
Yeah.
over 6.
And you get negative 1.6 or negative 1.7.
Yes. So whenever you type this in, negative 10 divided by 6, you're going to get a repeating decimal. So you have a few options. What I usually like to do is just write that first decimal and put a line over it to show that it's repeating, which would look like this. So I would say equals negative 1.6. The 6 repeats, so we put a line over it. I would also be just fine with negative 1.67 if you wanted to round up that decimal. So either one is fine with me. And yeah, there's copies up there. And how about negative 11 minus 1? I want to give someone else a chance. Rhonda.
Negative 11. Oh, is that what I'm supposed to be doing?
Yes. What's negative 11 minus 1?
Negative 11.16. Repeating.
I'm trying to think. Is that what just the minus 1, or did you go further?
We got the first.
Yes, we got the first one. We got negative 1.6 repeating. You got that one?
Mm-hmm.
Okay, perfect. So now we're going to the subtraction problem. Negative 11 minus 1. So let's see what just that part is. What's negative 11 minus 1?
Oh, it's negative 12.
Yes, negative 12. And what should I do next?
Divide that to 6.
Yes, divide that by 6. And negative 12 divided by 6. We get a nicer number, negative 2. Good. So our answer for number 4 is x equals negative 2, comma, negative 1.6 repeating. Right. And that is the whole first page. I'll leave this up for just a moment before we move on, but also remember this is being recorded, so if you don't get everything written down, it will be available on Google Classroom right after we finish today. Before we move to the next page, do we have any questions?
I have a question.
Yes.
Can we say x equal -1.6 repeating, comma, -2?
Yes, that's a great question. Bichel wanted to know, basically, does it matter which answer I write first? It doesn't matter because this is not a coordinate. So I'm not gonna worry about if I write -1.6 repeating first and then -2, or if I write -2 first and then -1.6 repeating. As long as the correct numbers are there, it doesn't matter which one you put first. Great question.
Yeah, thank you for asking.
Yes. Same with number 3. It doesn't matter if you put 3 first or if you put it last. I will take it as long as the right numbers are there. Awesome. Okay, so let's go ahead and look at page 2. That's all the questions for unit 1. Now we're going back to unit 2. And guys, I tried to be really nice. I only gave you one substitution problem, one elimination problem. That's it. That's all you have to do for systems. Now, because there's only 2 questions, these questions will be worth quite a few points. Meaning, if you get just part of it wrong, you're not going to lose. Let's say it's worth 6 points. You don't lose all 6 points immediately. You will just get partial points taken off for partial mistakes. So take your time with these. I'm not making you do a million of them, just 2, just to show me that you understand. So we are going to solve number 5, the system of equations by substitution. I gave you lots of space. And normally with substitution, we see one equation at least that has y equals. Neither of these are written as y equals. So the first thing we need to do, and I'm going to write a little step guide here. Step 1, we need to rearrange an equation so that it says y equals. Or you can rearrange to make it say x equals. We just need to get one variable by itself. Rearrange one equation to get either y equals something or x equals something. It doesn't matter which one you choose, and it doesn't matter which equation you do it with. When I'm looking at number 5, my first thought is I might just do the bottom equation because it's second on the list, and because I can rearrange it without rewriting it, it's just right here, and it's going to save me a little bit of space. I don't think either one will necessarily be easier than the other. So all we need to decide now is, do we want x by itself or y by itself?
I think y by itself, because that's gonna make it the most positive.
Yes. Okay, so Ella said she did, let's get y by itself. So how did you get y by itself? What did you do first? Yes, so I need y by itself. That means I need to get rid of the negative 6x and eventually that positive 4. So Ella started by adding 6x to both sides. And that would cancel my x's. I bring down 4y equals, and what do I write down here?
30 plus 6x.
30 plus 6x. You could also do 6x plus 30. Either one is correct. I like having my variable first, so I'm going to write 6x plus 30 But if you write 30 plus 6x, that's also okay.
I get it. Or 6x,
Yeah.
what most equations are.
Yes. So I'm going to write 6x plus 30. And now I have 4y equals 6x plus 30. Is y by itself? It's almost, we're very close. What else do I need to get rid of?
4.
The 4. This is 4 times y. How do I get rid of times 4?
Divide.
Divide. Now, because we don't just have a number by itself on the other side, we need to be careful that when I divide by 4, I'm dividing everything by 4. So I'm dividing 4y by 4. I'm dividing 6x by 4. I'm also dividing 30 by 4. Okay? We divide everything by 4. Now, you will get some decimals, and that is okay. We can use decimals. So I will bring down y equals, and now I'm going to divide both of these remaining terms. I have 6 divided by 4, and that gives me 1.5. 1.5x plus, what is 30 divided by 4?
7.5.
Good, 7.5. So now I have y equals 1.5x plus 7.5. And I'm going to circle this so that I don't lose track of it. I know now that y by itself can be written as 1.5x plus 7.5. Now that I've finished step 1, how can I use the other equation to solve for one of my variables in step 2?
Yes. Sorry, excuse me.
Yes.
Why you say minus 2y plus 4y equals 4y?
Because this is substitution, not elimination. With the elimination, we add them together. Is that what you're asking?
Yeah, that's the way I done it.
Which way?
I put 2 on in front of the -6. I put -2 right there.
So for number 5, I need you to show me that you know how to do substitution. If you do elimination, it's not the right method, so you won't earn all your points. I need to see both methods. So substitution is different, where we have to solve for one and then substitute it into the other equation. Is that what you were asking, Jean, or are you asking something else? You said something about minus 2y?
Yeah,
Okay.
plus 4.
Plus 4y?
Yes.
Okay. So, because we are using the substitution method, we can't just add them together. That's elimination. Substitution is a different way of solving. We have to follow different steps.
When you add,
Hmm.
then you have to when we start again, football can be the chance. This is when you can the substitute.
Keep asking about why didn't we combine the negative 3y plus 4y. Basically, he doesn't understand.
Doesn't understand why we're rearranging it.
I do add the justify category. Why is that?
No, scatti business nel cattiveria di parte non va. Viene ma questo.
I'm not sure how to explain it properly. The reason we can't do that is because that would be elimination. And we're not using elimination for number 5. We have to use the substitution method. It's just a different method. So we can't just add the equations together. I know, I wonder if Jeremiah's pretty good at explaining stuff.
So when we do this.
He might help.
We only have one equation. I don't know what open. So like, if you will look, like, let's take a look at this. What's the equation you see? Go with the bottom one.
Yes, we decided to
So,
rearrange the
when
bottom.
you are rearranging this and trying to substitute, it's like we're working with only one equation at the beginning.
Mm-hmm.
We can completely just cover up that second equation. And we're trying to say this variable is equal to these other things. It's just
Right.
another way to equate.
I think it might start to make sense if we go through the rest of the problem and we see how they go together. Let's finish the problem and see if it starts to make sense. So step 1 was we rearranged one of the equations. Now step 2 is we're going to plug this value in for y to the other equation that we have not used yet. So plug in either the y equals value or the x equals value that you just found to the other equation. So I'm going to now use negative 3x minus 2y equals 15, but instead of y, I can write 1.5x plus 7.5. That way, I don't have x's and y's, I just have x's. So let's write this. I'm going to bring this down. Negative 3x minus 2, instead of y, I'm writing this. 1.5x plus 7.5. That's my y. Equals 15. So this is my step 2. This was 1. This is 2. Once you plug something in, what do you do next? Distribute. We have to distribute this minus 2 into the 1.5x and the 7.5, right? So basically, step 3 is distribute. Okay, so negative 2 times 1.5x. What
Negative
is
3.
negative 3x? And then I'm done with that. Now negative 2 times 7.5.
Negative 15.
Negative 15. Okay, and then we bring everything down. Now I have negative 3x minus 3x minus 15 equals 15.
You get rid of the same operation, then just.
Get rid of the same operation. What do you
Like
mean?
negative 3x and negative 3x cancel out each other, right?
Do they?
Don't you add those together? You like to-
We gotta combine like terms.
Yeah.
Guys. These are on the same side of the equation, and
Yeah.
it's like saying I have negative 3 minus 3. You're adding 2 negative 3's together.
Yeah.
So
You
step
got
4,
negative 6 and-
let's combine like terms.
Yeah, that's what I'm talking about. Do something.
Okay, so 3, we did it right here. Now 4, I have negative 3x and another negative 3x. What is this together?
Negative 6.
Negative 6x. Bring everything down. Minus 15 equals 15. And now we just need to solve, right?
Yeah, add 15 to each side.
Okay, so add 15 to each side. And I still have negative 6x equals 30. Good. Divide by negative 6.
-5.
Yes. And I get x equals negative 5.
Basically what I got for the first question.
And you should get the same answer using elimination.
Yeah.
I just you just got to use substitution for this one.
Yeah.
Okay, so we have our x. Have we solved the whole system though? No, now I need my y. And luckily, we already have an equation here that we've rearranged to where I already have y by itself. Could I just plug this x in to there?
Yeah.
Okay, let's do that. So the last step, I guess step 6, is plug in to the rearranged equation. So, bringing this down here, step 6, I'm going to rewrite this problem. Y equals 1.5. Instead of x, what am I writing?
-5.
Negative 5 plus 7.5. That's the equation. And from there, we just have to do the operations that are given to us.
You distribute 1.5 times -5.
Yes. So we will start by distributing or multiplying 1.5 times -5.
7.5. 7.5 plus 7.5 is 0.
Look at that. So again, 1.5 times -5 will give us negative 7.5. I will bring down plus 7.5. And I bring down y equals, and you are correct. But now we look at negative 7.5 plus 7.5, and that does equal 0. Now we have our x and our y. And so what would our coordinate be? -5, 0. Good. Okay. Substitution can be a long process just because there's lots of rearranging and plugging in to do. But as long as you're careful about what you're putting into what spot and you're taking your time, really making sure that what you cross out makes sense to cross out when you're adding and subtracting all your terms, it should be a very smooth process. Now, before we move on to the next thing, I do want to make sure everyone feels okay about it. Do we have other questions or anything we're confused about with number 5? I'll give everyone a minute to kind of look it over, write it down, and let me know if there's anything we want to discuss. Yes.
I think there's problem.
Mhm.
When we're like dividing by 4,
Yes.
do you have to keep, I don't remember doing that. So you have to do that with everybody?
Do you have to do it on, say it one more time?
You have to do it each time.
Each time. Well, it's just if you divide one thing, you have to divide everything. It would be like, let's see. Let me give another example. Like if I had 4x equals 28y plus 12. Basically what's happening here is to get x by itself, I divide by 4 on one side, I divide by 4 on the other side. And you get your x by itself, but I can't just divide one thing by 4. I'm dividing everything by 4. So over here, I just wrote it twice so that we wouldn't forget and only do the 6 or only do the 30. Really, you only need to write 4 once, but we need to know that each of these terms is actually being divided because 28y plus 12 divided by 4 is going to be whatever 28 divided by 4 is and whatever 12 divided by 4 is, which, let's see.
7y
Yep.
plus 3.
7y plus 3. And we know that this is right because if I were to flip-flop the operations and if I had 7y plus 3 times 4, like this, if I distribute that 4 and I multiply both, 4 times 7y is 28y. Plus 4 times 3 is 12. Just like, I'll use the numbers from our problem. Just like here, I had 4y equals 6x plus 30. If I divide by 4 over here, it doesn't make sense just to divide one thing by 4. I need to divide all of it by 4. So that I get y equals 6x plus 30 divided by 4, which is really, we're dividing, it's like we're distributing the division now. We're doing 6 divided by 4 and 30 divided by 4, which gives us the 1.5x plus 7.5. And we could think of this in reverse as well. If I had 1.5x plus 7.5 times 4, when I distribute, I should get that original problem again, which is 4 times 1.5 is 6x, and then 4 times 7.5 is 30. So it's an uncomfortable thing to do because most of our equations we are able to reduce to one term on each side and that's it. But in this case, we have one term on this side and 2 terms on the other side. So we just have to remember that when I'm dividing everything. So that's the only reason I wrote divided by 4 twice. It's just so that I don't forget that I'm not just doing it to one. But I mean, does that explanation make sense to you? Does that? Okay, good. We have other questions. Are we ready to move on to number 6? Does anyone need more time or more help? Okay. So I'm going to go ahead and move to number 6. Now we have a system of equations and we're solving by elimination. So now we get to do the method that you all have had much more practice with. So first thing we need to do is look and see whenever I add my equations together, does anything cancel out? Nothing's going to cancel, is it? What do I need to do here? Titania.
I did the top one by -6
Okay.
and the bottom one by -8.
Okay. So you could do that. Since you're multiplying by the same sign, could I also use a +6 and a +8?
No, they have to be the opposite of each other.
Okay, so actually, because we have a +8x and a -6x, they're already opposite.
Yeah.
As long as we multiply both equations by the same sign, you could multiply by negatives like you did, but you could also do it by positives. It will still work. It will still work. Michelle, yes.
Level of elimination are we doing?
This is level 3, if you want to make a note. This is level 3, which is where we multiply both equations. So we've decided we want to get our x's to cancel. I don't really need to do anything other than multiply the equation by the opposite number. So I'm going to multiply the top equation by 6, and I'll multiply the bottom equation by 8.
It's negative, wasn't it?
I'm going to do the same signs because if I multiply by -8, that's going to turn this into a positive number, right? Because a negative times a negative. And then I'll have a positive and a positive, and that won't cancel. We need opposite signs. So let's keep going. Let's see what this gives us. I want to distribute, and I'll start by rewriting my top problem. So, what is 6 times 8x?
48. Negative 48.
I'm gonna
It's 48.
48x. Now I have 6 times -3y.
18 one.
Not just 18. Yours is gonna be a little
Negative
different. That's
18y.
okay. -18y. And 6 times 22.
132.
Yes, 132. So I'm going to write an arrow so we know that that's where that came from. And now we want to distribute the 8 into the bottom problem.
48.
So let's give some other people a chance to answer. What will I get for my first term? 8 times -6.
Negative 40.
Good, -48x. And then my next term, 8 times -8. Thank you, -64y equals
Yeah, 32.
8 times 4, yes, 32. Okay. Now, this whole process, especially whenever you are distributing, you need to be so careful and take your time and be so slow that you are including the correct signs. If I accidentally make one of these a plus, my whole answer is wrong. It's going to mess up the whole rest of the equation. We need to make sure that we are including the right signs. So once we've multiplied both equations, now we can do the part where we actually eliminate a variable. We're just going to add everything together. And when I do that, what gets canceled out?
48.
My 48s, my x's. My x's end up canceling out. 48x plus -48x is 0. What am I doing next?
You're adding -18 plus -64.
Yes, we're just going to keep adding terms down the line. -18 plus -64.
Y.
And I get, yes, -82y
Equals
equals,
164.
yeah, and then we just add the rest. Let's see, 2 plus 2 is 4, 3 plus 3 is 6, bring down the 1. -82y equals 64. And once we're caught up to here, somebody else, what do we do next? Divide. What am I dividing by? Negative 82 on both sides. Okay, and that will leave us with y equals 164 divided by negative 82. And I got negative 2. Are you guys getting the same answer? Negative 2? Good. Y equals negative 2. Halfway there. I would say more like 3/4 of the way there. The next part of this problem does not take as long. Once you find one variable, the rest is a lot faster. Bless you. So I have solved for y. Where do I go from here?
Go back up to your second problem, the top one.
Okay, so go back up to my problems. Does it matter which one I use? No, it doesn't matter. I can now take my y value and plug it in to either equation. It does not matter. Which one should we use? Somebody tell me. Top one? Okay, I'll use the top one. So I'm going to write 8x minus 3y instead of y, negative 2. Good, equals 22. Once I've plugged that in, what do we always do after we plug something in? Distribute. We're always going to distribute. I've got negative 3 times negative 2. Yes. Bring down plus 6. Bring down 8x equals 22. And now you've got an equation that you are all comfortable with solving. This is like a normal one. We can just subtract 6 from both sides. Bring down 8x equals 22 minus 6, correct? 16. And very last step.
Divide 8 from both sides.
Yeah. Divide 8 on both sides.
And 8 cancel.
And 8 cancel. X equals 2. Good. What is my coordinate?
2.
Ooh, yes, careful. X comes first, then it's y. 2. Negative 2. Good. Very, very good.
Everything's on a graph, it'd be -2 too.
X always comes first.
Oh.
So, you might be thinking of slope, because slope is actually like the rise is the y. But you're okay. Yes, x is 2, y is negative 2. That is our coordinate, and that is number 6. So, I'll leave this up for just a moment, allow you guys to take a look at it, finish writing, tell me if you have any questions, and then we're going to move on to the third page. Okay, moving on. That was unit 2. Now we're all up to unit 3, absolute value. This should be a review because we just did it. So for this page, something that I would really, really be sad if you all missed a point on is not answering number 7. Number 7, I drew an arrow. It says, remember, absolute value is always what? Positive. This is a free point. Write positive. That is free points. If you don't write it, you can't earn those points back. I'm not going to let you write it in later. Sorry. You have to write it. Positive. Don't forget to do that. If you think you might, maybe like circle it and put like a big note on your practice quiz. Like, answer that question. Always positive. That's so important. So for numbers 8 and 9, we're using these values. It says evaluate each expression using the given values for x, y, and z. So x is -5, y is 2, z is -4. We are going to plug these in for number 8 and 9. And what I would really like to do, and what I would recommend doing, is go through each variable, and I'm going to say I know x is -5. Everywhere I see x, I'm going to write -5 on top. So there's an x here. I'll write -5. No more x's. I'll go to the next problem. I see an x here. I'm going to write -5 there. Next, I'm going to see, where do I see a y? I don't see any y's, see Jeremiah, in number 8. So I'll move to number 9, and there's a y at the beginning. Y is 2.
Z is -4.
Yep, and then next we have z is -4, so I'm going to plug in -4 anywhere that I see the letter z. And there's a z in both problems. So I've gone ahead and done that. That's just going to make solving these even easier as I focus on each one. So I'm going to go ahead and zoom in to number 8, and we'll focus specifically on this problem. So when I rewrite the problem, let's bring everything down one piece at a time. I'm going to rewrite my 4. I'll bring down my absolute value bar. And then what goes next?
-5
-5.
minus -2.
Is it minus -2?
Or -2.
Yeah, there's just -5, and then technically it's -2.
Yeah.
-2. What's after
Absolute
that?
value
Absolute value
plus
plus
absolute value.
absolute value
-4.
-4.
Absolute value.
Absolute value. Okay, so we've done that. We've done that. Now, thinking back to our steps, step 1 was to plug in the values. Okay, so I'm going to write that. Plug in values. Step 2, we're going to simplify absolute values. So simplify absolute values, meaning we want to get each of these by themselves. We want to get it to where there's just one number inside the bars. So in my first set of absolute value bars, I have -5 minus 2.
7.
Almost -7.
Yeah.
-5 minus 2 is -7. I'll bring everything down. Bring down my absolute value bars because I haven't done that yet. I bring down, what else?
4.
4. What else? Plus
Absolute value.
absolute value.
-4.
-4.
Okay.
Good. Okay. Are my absolute values simplified?
No.
Okay, so what do I need to do?
You gotta change your -7 to +7.
Yes, remember, absolute value is always positive. So all you got to do is, if it's a positive number inside, just get rid of the bars. If it's a negative number inside, get rid of the bars and the negative.
Yeah.
Turn it positive. So this is
4 times 7.
7, and yes, thank you. This is multiplication. We have 4 outside of the absolute value of -7. If there's no plus or minus in between that, it's multiplication. So we have 4 times 7
Plus
plus
4.
absolute value of -4 is +4. Good. So now, what should we do?
Take 4 times 7.
Yeah, 4 times 7.
28
28
plus 4
plus 4.
and 32.
32. That's your answer. There you go. We're just doing one little simplification at a time, step by step, until we reduce the big problem into one single number. That is the goal. And we've done it. So I'll leave that up for just a moment. If you have questions, please let me know. And then we'll move to number 9. I'll leave that where we can still kind of see it, but we'll peek ahead at 9. Number 9, we've already written the values above the variable. So I'm going to go ahead and rewrite this whole problem, but instead of y, z, and x, we're going to write the 2, the -4, and the -5. So I have 2 minus 3, good, absolute value, -4,
That's fine.
plus,
Plus absolute value.
good, absolute value,
-5
-5,
-5 absolute value.
yes, yes. Okay. So I have 2 minus 3, absolute value, -4, close the value, plus absolute value, -5 minus 5, close the value. And we've got everything plugged in. So we're done with step 1. Step 2, we need to simplify our absolute values. So I'm going to ignore everything that is not inside absolute value bars, meaning I'm going to ignore 2 minus 3. I'm going to ignore the plus sign. I'm just looking at the absolute value of -4, and I'm looking at the absolute value of -5 minus 5. What should I do at this step?
2 minus 3 times 4.
No.
So we don't want to do that yet. We want to, at step 2, we're just looking at what's inside the bars. We will eventually do that. But let's see, if I don't have just one number inside the bars, we should reduce that first. This already has one number, the -4. What about this?
That's gonna be -2.
Yeah, let's kind of combine all of that. I have -5 minus 5, which you are correct, is -10. Absolute value. Bring those down. And now we want to bring down the rest.
Plus absolute value -4.
Mm-hmm.
Absolute value. And then 2 minus 3.
Yeah, 2 minus 3. Okay, now before, again, we still have absolute value bars in our problem. We can't mess with anything on the outside until we get rid of the absolute values. So what will I do with the absolute value of -4? And let's give somebody else a chance.
It'd be 4.
It'd be 4, okay? But what's happening with that 3 on the outside? Yes, times, multiplication. So I get rid of this, and it becomes +4. That 3 out here is being multiplied. So I've got 2 minus 3 times 4
Plus 2.
plus, same thing as that absolute value of -4. That's just going to be +10. Now, at this step, don't you dare do 2 minus 3.
It's 2 times 3 times 4.
That's going to make me really upset because we are using
Basic operation.
right basic order of operations. That's pre-algebra stuff, you guys. If you forget them, I don't know what to say. Your PEMDAS, come on, let's write it. PEMDAS. parentheses,
Exponent.
exponents, multiplication, division, addition, subtraction. Addition and subtraction come last. What am I doing first?
3 times 4.
3 times 4 is
12.
12. I'll bring down that minus because it is technically -3. So 12. Now I have, bring everything down, 2 minus 12
Plus 10.
plus 10.
Now you take away 2 minus 12 is 10.
Mm-hmm.
Plus 10.
Almost. It's not positive 10, is it?
Negative 10.
Ah, -10. Now this part, you can actually just type it all in your calculator if you want. 2 minus 12, -10, plus 10 is 0. 0. 0 is your answer. All right, so that is number 9. Number 9. And we really are almost done. We just have 10, 11, 12, 13. There's 4 more. And that's it. I didn't give you too many problems, just 13. Okay. Any questions about absolute value expressions before we go on to equations? Okay, let's look at number 10. Solve each equation for all values of x and then graph the values. So, what is the first thing that we need to do in an absolute value equation before we split it up? Isolate the absolute value expression. That means let's get x minus 10 by itself. What should I do? Uh-huh. Subtract 5 from both sides. Then I'll bring down x minus 10 equals
-3.
2 minus 5 is -3. Uh-oh.
That's it. No solution.
No solution. That's a problem. Yeah, there's no solution. There's no, you can't give me any number for x that when I give the absolute value of that minus 10, absolute value is always positive. There's no solution. Wow, I didn't even mean to do that, guys. That's actually my fault. Well, that's no solution. Sorry. I don't think.
That was easy.
I know, that was easy.
That was pretty simple.
No solution. Okay, so number 10, that's it. No solution. Now, I cannot promise you that there's going to be a question like that on the actual final. Just know if you get this, there's no solution if it's negative. Good catch, you guys. How about number 11? What should I do here first? You said add 1? Let's do it.
Both sides.
Add 1. Okay, so 18 equals, and I'll bring everything else down to absolute value 4x minus 3 equals 18.
Now you divide 2.
Good. Remember, that's 2 times the absolute value expression. So to get rid of it, we divide by 2.
4x minus 3
Mm-hmm.
equals 9.
Yes. So I have 4x minus 3 equals 18 divided by 2 is indeed 9.
Now you add 3.
Oh, now wait.
Oh.
Because we got to do something special here.
We're splitting it up.
Yes, our absolute value is all by itself. Now, Titania, you are 1000% correct. That is what we're going to do after this.
Yeah.
But
I forgot
before,
the other problems.
that's okay. That's okay. That's why it's good to run through these because we would have got half of it wrong.
No, I got it completely. Okay.
Oh, you
I'm
did
done.
it? Okay, I got you. All right, so let's split it up. Now, when I say split it up into two equations, what is the part that's different about each one?
Yeah, equal 9.
Yeah, your answer. So you'll have a positive 9 and a negative 9. So 4x minus 3 equals positive 9. 4x minus 3 equals negative 9. Okay. And we just solve them like normal.
Yeah, 3 on both sides.
Yes. Add 3 to both sides.
Well, we divide 4.
Divide 4.
You can get a decimal.
You shouldn't get a decimal for this one, but you might on the next.
No, you get 3 on that one.
Yeah, you
X
get 3.
X equals 3.
Good. So I get x equals 12
I
divided
was
by
looking at my
4.
line graph. That's fine.
You're okay. You're okay. X equals 3. And now I'm going to look at my equation with negative 9 as the answer. Do I do anything different for my first step?
Do the same thing.
I'm going to do the same thing. It's still 4x minus 3. My operations do not change. I'm still adding 3 to both sides.
4x equals negative 6.
Yes, negative 9 plus 3 is negative 6.
You divide 4 from both sides.
Divide 4, and you'll get a decimal, and that's okay.
Negative 1.5.
Good. X equals negative 1.5. And on your graph,
Negative 1.5 goes first.
negative 1.5 goes first. That's the smaller number. And then 3. Okay, so I'll leave that up for just a minute. Let everybody get caught up to there. And as you are writing, I do want to just bring the time to our attention. It is 2:06. I know this is normally the time I would give you a break. If anybody needs to step out of the room to get a drink, use the restroom, anything like that, you are so more than welcome to. We are going to keep going. Know that if you miss anything, it is all on video. So really, you're not missing anything. Just make sure that during this week, if you miss any part of this in person, that you come to me later and let me know. Yes.
What are you do again?
Oh, we're going to be going over that in just a minute. We're not there yet. I'll show you on the calculator, though.
Going on?
Here, let me pause this so I can look. So we're going to go ahead and flip to page 4. And let's see. Now we have 2 absolute value graphs. And these are the last 2 questions on the final. This is it. Besides, I did give you 3 bonus questions, and we'll go over those soon. But for page 4, we want to, let me make that big again, my bad. We want to make a little note of all the information that we need for these types of problems. So, remembering back to all of the graphing of absolute value, we have, I forgot to write y equals. Okay, well, that's all right. We have a absolute value of x minus h, absolute value, plus k. And remember, our slope is what letter gives us slope? It is rise over run. A gives us our slope. A over 1, we could say it like that. Or just A, rise over run. And our vertex, which variables give us the vertex? H and K. And which one is the opposite? H. Don't forget, if it says minus H, H is positive. If it says plus H is negative. So I'm going to write opposite for H. So you will notice for each of these problems, I give you a graph. Under the graph, I give you a spot to write your vertex, a spot to write your slope, and an XY chart. I want you to fill all of that out. So for number 12, let's identify our H, our K, and our A, H, and K. What is my A? -4. Good. A is -4. What is my H?
+1.
+1 is H. And what's my K?
5.
5. +5. Let me grab, where's my blue pen? I don't know. Oh, here it is. Okay, so we can use those. My slope is A.
-4/1.
So it's -4/1. And my vertex?
1, 5.
Good. It's just your H and your K. So 1 and 5. Now, a good note to make on here might be the vertex is the starting point. In case you ever forget. So, my vertex is 1, 5. X is 1, Y is 5. So, I'm going to go to my graph and look for 1 on the x-axis right here. And 5, I go up here on the y-axis. So here's my first point. This is my vertex.
This is negative.
Yes, now our slope is negative. We have -4/1. So we go down 4, left and right 1. Okay, so from my vertex, I count down 4. 1, 2, 3, 4
over
1. And again,
down.
1, 2, 3, 4 over 1. And now I've got enough points on this side.
You do the same, go back up to the top and do it to the left side.
Yes, now we just want to go right back up to the vertex. Same thing, but left instead of right. So I go down 1, 2, 3, 4 over 1. And again, 1, 2, 3, 4 over 1. And now I have all the points I need. We just need to connect the dots. Once we've done that, we do still need to fill out our XY chart. So I'm going to start by labeling each of these blank spots with A, B, C, D, E. And I'm going to label all my points from left to right. So my first point be here, A, I'll go up, B, C is what I like my vertex to be. Now, if your points are not in the same order, that is completely fine. as long as your coordinates
Matches.
are, yes, they need to match the point that you've labeled. So I have A, B, C, D, E. So, what is point A, titanium?
-1,
Uh-huh.
-3.
-1 is my X, -3 is my Y. Good. Somebody else, what is my point B?
0.
Bichelle? Oh, I'm sorry, Angel.
I don't know.
Go ahead, Bichelle. You go. And then Angel, I want you to get the next one.
0, 1.
0, 1. Good. 0, 1. Okay, Angel, you got my next one?
1, 5.
1, 5. Perfect. And point D. I want to give somebody else a chance here. Point D, Rhonda.
2, 1.
Yes. 2, 1. And last but not least, E. Who's got E? Kelsey.
3 negative.
Yes. 3, -3. There it is. Good job. Okay, that is number 12. Number 13 is the same thing, just with different numbers. I'll give everyone a minute to get this caught up and copied. I'm going to move that little sticky note over. Let's go ahead and look at 13. Number 13, I have 3, absolute value of x plus 2, absolute value minus 5. What is my A, my H, my K? What's A?
A is 3.
A is 3. What's my H?
2.
2. Oh,
-2.
-2. This is the
That's
hard part.
opposite.
Remember, H is opposite.
So it's positive. -2.
Yes, so H, in case we forget, just remember, maybe make a note on your practice final. If it's plus a number,
It changes.
it's negative. If it's minus a number, it's positive. So my H is -2. And what's my K?
-5.
-5. So now that I know those 3 numbers, I know my vertex and I know my slope. What is my vertex?
-2, -5.
Yes, -2, -5.
And slope is 3/1.
Mm-hmm. My slope is 3/1. So I have a positive slope. Will I still go down like last time? No. Positive, we rise up over 1. Rise 3, run 1.
On your first point.
Yes. So all we got to do now is vertex, then slope. My vertex is -2 for x, -5 for y. I find -2 on the x-axis. I go down to -5 on the y. So here is my vertex. And from my vertex,
Up 3/1.
yes, we use slope. Slope says go up 3 spaces, go over 1 space. So we'll do just that. 1, 2, 3 over 1. 1, 2, 3 over 1. And that's enough points. 1, 2, 3.
Go to the left.
Go back to the vertex. Same thing, but over to the left. Up 1, 2, 3 over 1 left. Up 1, 2, 3 over 1. There we go. I'm going to connect those points, draw my lines, and then we'll label. Yes, and then this is it. This is your practice final, other than the bonus.
We didn't even go over none of them problems, so I didn't even do none.
No, you will have no idea how to do it unless you looked it up online or you learned it previously, because we didn't even touch the bonus. It's new stuff.
That we didn't even learn.
Yes.
I was like, yeah, I didn't even know that. I looked at that stuff, I was like, no.
Okay, so let's label our coordinates. Again, I like to go from left to right, letting C be my vertex. So I will start here with A, then B, vertex C, then D, then E, and I will also label my XY chart. A, B, C, D, E. So, Titania, I'll let you name my first point, and then I want to hear from some other people. What's A?
-4, 1.
Good. -4, 1. Who's got B?
-3, -2.
-3, yes, -2. Perfect. -3, -2. What is C? Who's got C?
-2.
Good. -2, -5. Who's got D? It might be someone else's chance. Somebody you know. Jalen?
-1, -2.
-1, -2. Very good. And last but not least, who's got E? Picha.
0, -0, 1.
0, 1. Very good. Very good. That is it. I will leave this up for a minute. And then we're going to look at those bonus questions. If you know that you don't even want to try the bonus, you are more than welcome to be done. However, the bonus really, it looks scary because we've never done it, but I promise you it's not that hard. It's really not. It makes a lot of sense once you see the process.
I'm gonna watch you do one, and then I'm gonna be done. I just take my final tomorrow.
All right. No problem. I know that it took a little longer than I thought it might. So anybody is welcome to start the final today once we finish, but I totally understand if y'all want to wait.
I don't.
Okay. Let's look at the bonus. So I gave you 3 bonus questions. These are exponential equations because sometimes we don't know what the exponent is. We can use equations to solve for an exponent, but we have to do some special things. So we're going to learn about that today. There are 3 bonus questions. Each one is worth 1 point. So you can get a point for solving just one of them. You can get 2 points for solving 2 of them. If you solve all 3, you get an additional half a bonus point. So you have a potential to get 3.5 bonus points for your final. So when solving exponential equations, we know that, or maybe we don't know, this might be new to some of you. I will tell you that with a term that has an exponent, I'm going to say, here's a number. Here is an exponent. So, for example, 3 and 4. My large number is called my base number. And this is the exponent, of course.
Okay.
If the base numbers are the same, you can just set the exponents equal to each other and solve like normal. So looking at this number 1, I have 5 to the power of 5x, and then I have 3 to the power of 8x minus 3. What is my base number here?
3.
3. What is my base number here? Also 3. Because they have the same base,
You just add your exponents, right?
not add,
Subtract.
not subtract. I'll show you. I'll show you. This is an equation that's already been written. Because the bases are the same, we can sort of cancel them.
Okay.
They go away. And now what's left is just the exponents in the equation. We're going to take 5x, set it equal to 8x minus 3. That's all we do.
Oh.
Set the exponents equal to each other. You see that? What would I do from here?
Just.
Like,
Wait a minute, wait.
Yeah, we're just solving it like a regular equation. We want to get x by itself, and or we want to get all the x's on the same side. So what's a good first step?
Wouldn't you, subtract 3 from each side? Or add 3?
I could, okay, I heard lots of different ideas. I could add 3 to both sides, but would that help me get my x's together?
No.
No. I heard somebody say something about the 8.
Yeah, add 8 to both sides.
Let's subtract 8x from both sides. Because that's going to get rid of my x's over here,
Yeah,
and it's going to bring them over there.
okay.
Minus 8x, minus 8x.
Yeah, so-
And that cancels. Now what's 5x minus 8x? Negative 3x. Bring down equals.
3.
Bring down
Negative 3.
negative 3. And looky, looky.
And
You
you
can
subtract
solve that,
3.
can't you?
Yeah, subtract 3 from each side. Or divide 3.
Divide 3. Yes. It's 5.
Negative 3.
Negative 3.
You're gonna get 0. X equals 0.
Not 0.
Oh, no.
Type it in. What do you get?
I'm doing it too fast.
Uh-huh. We got to slow down, girl.
yeah, 1.
You get 1.
Yeah.
Negative 3 divided by negative 3 is 1.
Okay.
X equals 1. That's it. You're done. You've solved it.
Oh, wow.
And that's not so bad. It's not so bad.
It's just the steps. So
Yeah, it's just the steps, and it's just knowing what you're allowed to do in math. It's rules you've never learned. Rules you've never learned. So we've got x equals 1 for number 1. We're
So
done.
same base cancel.
Yes, if the problem has the same base, you can cancel that out and just set the exponents equal to each other. So same bases cancel.
So what if they have the, so that's the same rule for the exponents too? If they're the same exponents, they cancel out with the next problem?
Well, if we canceled our x's, we can't do that because we're solving for it.
Yeah.
Yeah, we're trying to solve for x. And also, do we have the same bases?
No.
No, we don't. So now we take it a step further and I tell you what we do when we don't have the same bases. So for number 2, different bases. What we need to do when we have different bases is we need to make them the same. Is there any number that I can use for 4 that means the same thing as 4, but is written with a 2? Does that question even make sense?
That look like 2.
2 times
Yes,
2?
yes, it's 2 squared. We need an exponent. You're right, because guess what? 4 is the same thing as 2 squared,
Yeah.
right? So here's what we do. I'm gonna write this problem over again, okay? 2 to the x power, that's what we started with, equals, instead of 4, I'm gonna write 2 squared. but I still have x plus 6 in my exponent, right?
Yeah.
So I need to bring that over, but put it in parentheses like this, x plus 6. Do we see what happened? That's funky. That's a funny looking thing to do, but we can do it. I brought over the 2 to the power of x, and I brought over, I know 4 is the same as 2 squared. So I brought over 2 squared. And then I brought over x plus 6. Do we have the same bases now?
Yeah.
We do. So now that we have the same bases,
Yeah.
we can cross them off. And now I have my exponents are equal to each other, right? So I'm going to write at this point, I'm going to bring these over into a new equation. X equals 2 parentheses x plus 6. Are we following? Okay, wonderful. So what do I do next?
Don't you subtract x or add x?
Neither.
Both sides.
Distribute. Uh-oh, we got 2 outside of something in
Yeah.
parentheses. Yeah, that's all right. We got to distribute first.
So 1
2 times x is
2
2
plus 6 plus 12.
2x
2x
Yep.
plus
plus 12. You're right. So 2 times 6 is 12. So now I have 2x plus 12 on this side equals, just going to bring down that x. And now I have an equation I can solve. What do I do?
subtract 12 from no, subtract the 2 back.
I'm going to subtract 2x because I want to get my x's together, right? Let's do that. Let's subtract 2x from both sides. And what is, remember, this is 1x. What's 1x minus 2x?
Negative 1x
Yes, negative 1x equals what?
plus 12.
My 12. And very last step,
Right.
divide. Good. Divide by negative 1. Divide by negative 1. And we get x equals, what do we get?
Negative 12.
Negative 12. Very good. That's our answer for number 2. And number 3 is something very different. I have a feeling none of you have ever heard of this before. It's something that's really strange and really odd, but it just exists, and I'm just going to show you. Because for number 3, I have different bases. Is there anything I can do to make these the same bases?
And change it to 2 each.
Change it to, well, is there 2 to the something power that will equal 6? No. There's nothing I can really do here. So, there's a fancy button on your calculator that lets you do something that I don't even quite understand myself, but it works. So I'm just going to show you. Everyone look at your calculator and find the button that says log. This is a button that allows you to do something called a logarithm.
Oh.
Logarithm. So we're going to use that button Because here's the problem. You cannot solve a problem where your variable is an exponent. It's impossible. It does not work. We're going to do something really weird where we're going to put the exponent in front of the base. I'm going to write x. And I'm going to do something really weird. I'm doing x times the log of 6. We're going to take the log of both sides. What is the log? I don't really know. But it helps us find exponents somehow. So you're going to literally, on your calculator, this is what you're typing. Log, parenthesis, 6, close parenthesis. Okay, so what I'm writing down here is I'm writing log, parenthesis, 6, close parenthesis. I'm taking the log of 6, and I'm moving my x to the front. Then I'm going to write equals. I'm taking the log of 6. I need to also take the log of 8. So log of 8. So looks weird, doesn't make any sense. Here's how we solve for x. Really strange. This means x times the log of 6. I don't know, it just means that. X times the log of 6. If I want to get x by itself, remember this is just multiplication. How do I get rid of multiplication? Division. Let's divide by the log of 6. Stay with me. It'll all make sense. Because look what that does. It's going to get rid of the log of 6, and x will be by itself. But I need to do that on both sides, right? So I'm going to divide both sides by log of 6. And what happens is x comes down by itself, and I'm going to write here what you will type on your calculator. You will literally type log of 8, close the parenthesis, divided by log of 6, close the parenthesis. If you don't close it, you're going to get the wrong answer. So I'll type it in and show you. Log is right under x squared, right here, next to 7. So hit log of 6, close your parentheses.
Why do you do log of 6 first if you're doing log of 8?
Oh, you're right. Good catch, Ella. I'm wrong. Log of 8 is first. Thank you. Log of 8, close parenthesis, divided by log of 6, close parenthesis. You're going to hit enter, and that's your answer. That's it. And we can check it if we want. 6 to the power of x, or 6 to the power of 1.16, and so on, should give us 8 if I plug it back in. So let's try it. 6 to the power of, I'm going to arrow up and just include that. 6 to that power, it's very close to 8. So it works. Really weird, but it works.
So we just write that one.
You just write at least 2 decimal places. I would take 1.16. That's your value of x. So x equals 1.16, and that's it. So the hardest part of this problem is just remembering where the log button is. So.
Mom, where I click the slash?
The slash is divide, divided by. Yes. So really it's log 8 divided by log 6. That's how we do it. And make sure you close the parenthesis. If you don't, your answer will not be correct. Close your parenthesis. All right, that's the practice final, guys. That's a whole shebang. And it is 2:40. So right now our class technically ends at 3:30. That is 50 minutes. You have a little bit less than an hour. If any of you want to start on the final, even if you don't finish, you are more than welcome to get started on it. However, if you would rather kind of let this soak in, maybe watch the video tonight, really let it settle in your brain, you have the whole rest of the week to take the final. You have lots and lots of time. So at this time, if you are done filling this out, you are free to go. If you would like to stay and take the final, after I end the video, just bring me your practice final. I will mark off that it's complete and I can give you a final exam. And if not, you're free to go. So I will end our video, and that is all. Please let me know if you have any questions, comments, concerns, anything you need help with. I am still here to help you guys. This week is just for finishing the final, and that's it. The end.